So friends, a big hello to everyone. Why here, Gravity Graviorca channel. Today we'll look at my favorite machine. It's probably one of my top favorites. I've worked on these the most, I'm working on them now, and I'll likely keep working on them in the future. This is the JPT50LP machine. The source is from JPT, the LP series with a fixed Q pulse, respectively, and 50 watts of power. This machine is legendary because it's so easy to start and run with simple parameter settings. If you don't need any fancy stuff like color engraving or color interference, then this is, in my opinion, the best model. That is, it does good 3D engravings, it does initial beam ignition, meaning no delays like on the M7 or M8 series, and at the same time, it performs all its functions, well, more than confidently. So let's start with the fact that you don't need too much knowledge here. Like with the M7 series, you don't have to struggle with Q-pulse control. You set it up, start it, engrave, work, and get the final result you want. Polishing is also possible here on certain steels. You can't just put anything in there. And actually, the main functions are 2D engraving, white, black, saturated, material removal, polishing titanium, stainless steels, even stone works quite well here. Lenses from 100 by 100 to 200 by 200. Let's move on to the flash drive, and I'll show you what we usually give to clients, so they can be sure they'll work easily with a smooth startup, driver installation, software, and everything else. Let's start the review with our flash drive. Everything here is as simple as possible. That is, we'll have SCAD, version 2.14.16. It directly depends on the controller installed in the machine because controllers can vary. There are about 8 different types. We are currently using controllers. Version 2, so version 2.14.16 is our SCAD, and the controller is version V7. I also like version V4 controllers, and I really love version V2 controllers. These are cracked controllers for software version 2.14.10, and also for the Laser Amboss plugin for 3D, engraving without any difficulties. Photo parameters, we'll likely be moving away from them in the near future. I mean, it's just extra information we're throwing in, and people start misleading themselves with these photo parameters. Also, 2 pre-configured EasyCADs. Today we have a machine version with 2 lenses, a 100 by 100 lens. The main file is in the plug folder, the markcfg7 file. In the markcfg7 file, we can open it with any text editor, and it will contain all the information about your equipment. That is, the model, frequency range, rating, which ports, and the work area calibration is also specified here. Input, output ports, frequency ranges, upper level, lower level, basically all the information needed for your equipment to function. And also, don't forget that in this case, this file will be used by those who will use it for the correct setup of the Lightburn program specifically, so everything here is as simple as possible. Also, an important file. Again, some people need it, some don't. It's the lang file, langrussian.ini. Same thing, it just opens in any editor and you can enter any info you need. Like if you want to tweak a file for yourself, you change it and use it. So the configured drive on the flash drive is more than enough lately. I even practically copy these files to Yandex Disk so users can download and use them right away. Now, a bit about Yandex Disk. Yandex Disk, we provide an access link for our clients. The folder is called For Clients, and there's a short, clear video guide on how to use these files. What you can do here and what you absolutely must not do. Files. I update and add them here periodically. Let's start from the end. These are 2D layouts. I uploaded them from the main database. These layouts are about 30 megabytes. So basically, use them for engraving, cutting, whatever you need. All sorts of formats. You can use them for your own needs. But again, I'll repeat, someone might use these layouts for selfish reasons and register them as a trademark or a brand. Brand, logo, whatever. So you have to be very careful with these layouts specifically, or similar ones, that someone might register for themselves. Regarding SCAD, since we sell various equipment, it could be CO2 or UV lasers with completely different controllers. There are different versions of SCAD here. I tried to make it convenient for clients to use with their own gear or gear bought elsewhere. So different versions of SCAD that our clients mostly use. Accordingly, there are 2 Russian language packs, one I made myself, and the other is more or less taken from the standard version of SCAD. For the gray version, for the licensed one, instructions for working with ESCAD are all here in PDF format in Russian and English for your convenience. Other versions are offline versions or versions from other machines for different purposes. And tasks, same thing. They're updated and added here periodically, so it's very logical and simple. Fiber laser parameters is the most important folder in the heart of this Yandex disk, so clients don't have to set everything up from scratch themselves. From scratch for their layouts or templates. There are different templates for each machine. Today we'll use JPT50LP. There's a template database like this. It's almost fully configured, but there are certain nuances we don't set up here. I mentioned this in the manual, of course. There are parameters that are pointless to preset because they depend on individual goals. So I didn't set them. Each client sets them up manually for themselves, their machine, and their specific tasks. As for video guides, there are clips on how to set these parameters. The clips will be under Start ESCAD and so on. Driver installation and replacement, first launch, general settings. Then laser setup TC and the laser machine, setting laser parameters for engraving. So these two video files are very important files. You must watch them for yourself. Everything else was individually recorded. Again, the maintenance service for 30LP, 50LP. Extremely detailed videos on how to properly maintain your equipment. There's a general overview, an old video, and there are also other videos and materials that'll be useful for working with your machines. Again, the videos are on average 10 to 30 minutes long. I recommend watching them from start to finish, preferably all of them, and draw certain conclusions. That is, from these videos, you can learn how to work on the machine and prevent it from breaking. Documentation is essentially a collection of certain information from various sources, meaning they were gathered from different machines so that customers could also use them for their own equipment, whether it was bought from us or elsewhere. It's very convenient when you have more or less the documents for what you didn't have before. And probably the most valuable thing for me is the short instructions. Really great material. So here we have these short video clips. They're really awesome. They range from 1 to 3 minutes. There's no sound here except for a regular calm melody. And in text format, it's written here what you need to do in one place, what you need to do in another. So from 1 to 3 minutes, extremely intuitive videos. Driver installation, machine startup, service maintenance, mirror maintenance. So this is cool material. At least 2 to 3 hours were spent on each video. There are about 15 videos here, I think. If I'm not mistaken, 19 files. Well, yes, 19 videos, it turns out. So this is a very valuable resource. Maybe I'll record more later and it'll be like a micro tutorial for some, I don't know, symbolic cost so that people enjoy working. So there are answers to most questions here. Also a very cool topic. And accordingly, it all ends with the layouts. Let's get to work. We use pre-prepared layouts. There are layouts for lighters, meaning different structures and shapes. Both images and vector files are used here. In the wireframe view, you can see that raster plus vector is used. Let's set them aside. We'll be engraving specifically on the tag. We're interested in this format. We also have 3 different layouts, which is the tag image itself plus 2 vectors. What's the difference between them? The expanded view is object tracing, object detailing, line thickness, line width. We use this vector because the black structures here will be smaller in size, but plus, due to the laser thickness, more will be burned. So in this case, the layout will be used. The layout is tailored for our tags, so in this case, we'll apply it to stainless steel. We don't have titanium in stock right now. It would, of course, be more beautiful on titanium with deep material removal. Select the layout, Control-Shift-S, put it in the Downloads folder, tag lighter. Well, that's right, let it be 2's there. SVG format, only selected, and we put it in the same place. Click Save. Vectors, curves, without any text files. Click OK. Let's go ahead. With ESCAD running, press Ctrl-B to import a vector file. Token, lighter, 2's, show preview, put in center, meaning we place it in the center, and click OK. Loading. We know that this engraving inside our token, according to our template, is 24 millimeters wide. Set centering from the center with 24 millimeters with the lock icon closed. Click Apply. The token itself is being formed. What we're doing here is for object tracing and aligning it to our token. I'll ungroup it, which is Control U, ungrouping. Ungrouping again, and I'll copy the contour in this token, Control C, Control V, step down, step left, and assign a marker binding that we won't use here, let's say marker number 5. Bound it, go to color separation, separate only black tones, marker number 0, and go to hatching. There are many options in hatching. On the 50, we'll work with the crosshatch checkbox naturally. Material removal will occur on a bidirectional continuous line. Hatching density will be 0.02 millimeters, that is 0.02. We don't use align lines by edges here. There's no point in it. We won't use contouring here. Since we'll work with auto rotation, many passes. Auto rotation, we'll set to 25 degrees. Let's not get too bogged down here on how the structure, stripes, notches, and everything else will change. The hatching process is underway. Again, look at how much small details burn. If we see details burning, like teeth or other elements, we can offset from the edge. We won't apply it yet. This is a test template. Let's see what we get on the JPT50LP. Remove default settings on the right. Processing speed will be around 1200 millimeters per second. We'll set power to 60%. That's high, burrs will form. To compensate, we'll raise the frequency from nominal 200 nanoseconds fixed Q pulse to around 180 kilohertz. The Q pulse will drop automatically. Parameters I'm not setting here. In this case, these are parameters. Start TC, beam ignition, laser off, beam shutdown, and TC, shutdown during transitions, and polygon lines. It's better to set them. We'll set them to a random value of 80. In advance, I'll set jump speed, idle jumps, or laser skipping to 3000 millimeters per second. Start ignition, 140 and 120. These parameters will vary depending on the hatching method used. Unidirectional to bidirectional with line interruption or another method depending on the layout and processing complexity. Our task now is to do the layout removal. And there's the following nuance. Besides layout removal, to avoid burrs, we'll clean or polish it after each pass. So we've copied the layer that we'll need for tracing the object and positioning it on our token or template. There, and we'll start using it as a cleaning pass. We're using marker number 1, meaning the parameters that will be configured separately under marker number 1. I'll set the density to 0.01 millimeters to speed up the process. Bidirectional with interruption, no crosshatch. We absolutely don't need it here. Let's start with, say, 30 degrees to offset the initial start angle and prevent our engraving from overlapping with our layout cleaning. We'll also set the auto rotation to 25 degrees. Click Apply, and don't forget to link our marker at the bottom with the outline of marker number 1. Uncheck the default box. The processing speed will be 2000 millimeters per second. The power is already set at 25%. The frequency is 300 kilohertz. With these parameters, we get a nice clean material removal. The parameters here, like start TC, laser off, and NTC, will have a huge impact. The start TC value is approximately 90. Laser off is approximately 190. NTC is 90. Polygon TC doesn't play a role here, but for smooth transitions between lines, we'll set it around 110. In advanced, I'm barely going to touch the jump speed. I'll set the value to 150 and the other to 120. So our layout is ready. Press F1 and move on to the engraving process. We'll set the number of passes to 10. At the end, we'll do a general repolishing and use this layer for patination or blackening. We can set it up here in advance. Control C, Control V. Step down, step left. We'll apply the method again, checking Calculate All unidirectional with interruption. We're using marker number 2, which we'll apply at the very, very, very end. Before our engraving, we'll set the fill density to 0.008 millimeters, no contouring, no auto rotation, angle, 0, click Apply. Okay, angle 0, everything seems to work out well, and for the parameters we'll work with, we link the marker again and uncheck the default box. The speed will be around 300. The program froze a bit. We really overloaded it with the number of layers and processing complexity. Okay, speed 300. We'll set the power to around 25% and compensate for the pulse duration to avoid burning the metal around, well, let's set it somewhere around 130 kilohertz. This way, our Q pulse will drop about 3 times from 200. Start TC value is roughly 90, laser off. Around 170 for the beam and 90 here, polygon TC for us here. It won't play a very big role there. We can set the value to around 60. In advance, the jump speed value, we'll set it to 1000 so the jump jerks aren't as large. Here, 120 by 100, and click OK. We'll do 10 passes of removal plus cleaning, and then 1 pass of blackening. So upon completion, we have 2 engravings. The first engraving is on the tag. Everything here got burned, and accordingly, the tag warped. Power was 60%, frequency was 180 kilohertz. All the fine detail here is completely burned out. So basically, we change the fill density, lower the power, change the frequency range. They'll be more or less workable. Now, on the second tag, I didn't sand anything here. So we changed it, lowered the power to 35%. Raised the frequency range a bit higher, there's no sanding here. On this tag, accordingly. Here's the detail. Well, relatively speaking, we got it. The next point is that things with very fine detail are usually engraved at no more than 15 to 20% power on an f1.63 lens with a 100 by 100 work area. But here it's achieved by the fact that the number of passes, meaning the number of passes is increased, material removal and cleaning at the end, and only at the very end is the blackening done. I'll save the template. Maybe it'll be added to the list of layout templates we provide to our clients, or I'll add it to the Telegram channel. The link will be in the description. And from you, as always, a big thumbs up. And for me, more useful info. So a machine for universal work, material removal, engraving. Even in this case, the tag, basically just sand it a bit, polish it mechanically, and it'll be a finished working model.